All right, good morning. So at our last session, we talked about finding interior angles in a triangle. And today we're going to take that a little bit further. We're going to talk about finding what's called an exterior angle in a triangle. So the first thing that we're going to have to do is we're going to have to talk about what an exterior angle is. So an exterior angle, as you can see here, is the angle between the side of a shape and a line extended to the next side. So I have to extend a segment. So if I extend this line, I can call that X my exterior angle. If I extend this line, I can call that my exterior angle. If I extend this, that's my exterior angle. If I extend this, that's my exterior angle. If I extend this, that's my exterior angle. And if I extend this, that's my exterior. So in a triangle, you've got 6 different ways we can create exterior angles depending on which side you extend in which direction. And of course, it will always be supplementary to the adjacent angle. So if this is my exterior angle, and this was 30 degrees, since this is a straight angle, this would have to be 180 minus 30, which is 150, and the same would be true down here. If I extended this, it's 150 as well, because if I extend both of them, not that I would really do that, but if I extended both of them, you can see that they're vertical, and it's also going to be supplementary to that interior angle. So we're going to be using the vocabulary of interior angle, as in the angles inside the triangle, and exterior angle, which are the angles outside that we will only see if we extend one of the segments. We don't have an exterior angle until we extend a segment. All right, so how can we find the missing angle? Well, let's think about what we would logically do first. Well, I'd probably want to find the supplementary angle, right? I'd probably want to find this. So what I would do is I would do 57 plus 82, and that gives me 139. And then I would say, well, if those two angles add to 139, then the missing angle is going to be 180 minus 139, which is 41. And so now this is 41. I know this is a straight angle. We just looked at the fact that these are supplementary. So this is going to give me 139. All right, so I don't want to say anything else yet, but let's just look at the work. All right, and we'll move on. So let's do the same thing here, right? I'm going to try to see if I can find this angle. So I can say what's 80 plus 40, that's 120. And what's the missing angle then? 180 minus 120 is 60. So I know that this is going to be 60. And how do I find X? Again, I've got my straight angle here, so 180 minus 60 is going to be 120. And at this point, and it may have happened a little bit with the first one, we'd realize something. Now, what I did the first time really solved the problem, right? 80 plus 40 was 120. And then what did I do? I did 80 minus 120 is 60, but then I went backwards and I did 80 minus 60 is 120. That's kind of like circular reasoning. So what can I probably do, right? I can probably just take those two angles and add them up. And if we see that applies to the first one, that's going to work as well. And ancient mathematicians figured this out very, very early on, and they came up with what's called the exterior angle theorem. So it says, exterior angle theorem says an exterior angle will always be equal to the sum of the two non-adjacent interior angles. So let's put that in plain language. This angle, the exterior angle, will always be equal to the sum of the two angles that are not next to it. Now let's see if we can come up with a very, very, very simple proof of why this is always going to be true. Right, so we're going to say that A plus B plus C is 180, right? We know that because they're interior angles in a triangle. But I also know that C plus X is equal to 180, right? Because that's a straight angle. So if both of these things are equal to each other, right? If A plus B plus C is 180 and C plus X is 180, I could say that A plus B plus C is equal to C plus X. So what do I notice? Well, if I subtract C on both sides, it leaves me with A plus B is equal to X. And that's exactly what we just, figured out. That's my exterior angle theorem in a nutshell, right? This is the language behind it, but this is the algebra, right? A plus B will always be equal to X for this very simple reason that we looked at here and here. So how's that going to help us now? Well, for something like this, I don't have to find this angle. I could, but if I understand the exterior angle theorem, I'm just going to say, well, that's a right angle. That's 20. This should really be 110. And if that's 110, then this angle here would be 70, and then my triangle would be 180. But this is certainly going to be a lot faster. How about something like this? Well, now I've got two options, right? If we didn't know the exterior angle theorem, this would still be solvable, right? I did this before with 80 and 40, right? That gave me 60. So if you don't want to do the exterior angle theorem, you would say that 60 plus 8x plus 24 is equal to 180. All right, which is not terribly difficult, but why don't we cut to the chase and use our exterior angle theorem, right? The sum of the two non-adjacent interior angles is equal to the exterior angle. This is going to be a little bit easier. So now I get 120 is equal to 8x plus 24. So I get 8x is equal to 96. So that gives me x is equal to 12. And if we want to know the measure of the angle, we knew the measure of the angle, right? I mean, we were going to sub it in to be sure, right? 8x plus 24. I'm going to sub in 12 for x. That's 96 plus 24, which is going to give us 120, which is what we expected. So what did we learn here? We learned that the value of x was 12, and that made the angle, which we knew initially, we knew the angle anyway, but in this case it was the measure of finding out what x was. And here's a good example of one that you can't do without the exterior angle theorem. I mean, you could, if you were very sophisticated, you could say, well, this is 4x and 5x, therefore this angle can be represented by 180 minus 9x, right? It's the supplement of 9x. And then you could say that that plus 8x plus 16 is equal to 180, and that would work. But if you're willing to go those lengths, you probably know the exterior angle theorem anyway, and that's going to make things a lot easier. So again, the sum of these two, and I don't even really need to be showing this step. I think at this point we can all add 5x and 4x in our heads, but I do want to show you where the work comes from. Should be equal to 8x plus 16. Now I've got 9x is equal to 8x plus 16. Now I'm left with x is equal to 16. So now I have to do a lot of substitution and then even a little bit of checking. So if x is 16, 5 times 16 is 80. 4 times 16 is 64. 8 times 16 is 128, plus 16 is 144. And again, there's no guarantee any of this stuff is right unless it actually checks. Is 80 plus 64 equal to 144? It is indeed, and that means that we did this correct. Okay, so there's your now try. These should be pretty easy. You should be able to use the exterior angle theorem and do this in about a minute or two. So for the first one, all I have to do is add my 90 plus 43. And that should give me 133. Second one does require that. Actually, it doesn't necessarily require algebra. If you want to find the acute angle here as 50, you can use the interior angles of a triangle, but I think we're better off using the theorem that we learned today. So I'm going to say that the sum of these two angles, right, 3x plus 5x plus 10, is equal to the exterior angle. So 8x plus 10 is 130, 8x is 120, so x is 15. And now we need to go back and substitute. So if x is equal to 15, 3x is 45 degrees. 5x is 75 plus 10 is 85 degrees. And 85 plus 45 gives us our 130, and there's our check. So again, guys, keeping consistent with what we've done since we've kind of started this little geometry unit, this would be our classwork. We'll call it our homework. So for each one, you're going to solve for x and, if necessary, substitute. So for number 1, you don't have to substitute. Number 2, solve for x and substitute. Number 3, solve for x and substitute.